Hey there guys, welcome to the notes video for 4.3 notes, writing equations. Now you've had some practice with writing equations in your Unit 3 packet as well as your Unit 2 packet. This is just a review and adding a little bit extra. Now first things, you've probably seen this chart before, but it's important to have it because we're going to reference it a lot. We have some general key terms that let us know our rate of change. Remember, rate of change means slope. So some key words for slope or rate of change are each, per, every, or a blank, such as a week, a day, an hour, so on and so forth. So anytime you see these words, it's kind of a hint to tell you, hey, I'm dealing with a rate of change, or the number associated with these words is my slope. Initial value is a little bit harder. There's more of a general pool of words to choose from, but some of them are starts, begins. So something that lets you know this is the beginning point or the initial value, which remember is just my y-intercept. Has, have, so anything in the past tense, such as he has 100 action figures or he already has 200 tickets. Anything in the past tense lets you know this is my starting amount. Something else is fixed. If we have a fixed rate, something that you pay no matter what, such as a delivery fee. A lot of times you pay the delivery fee no matter what, even if you order a lot of food or order a little bit amount of food. So these are my general key terms. Now looking at actual word problems, we're going to use these key terms to write equations. Now the first set of word problems are word problems in slope-intercept form. These are the ones you're going to be most familiar with. You know you have word problems in slope-intercept form when you have something in a constant rate and you're given an initial value. And when these two criteria are met, we should be writing our equations in slope-intercept form. So for example, an airplane 3,000 feet above the ground begins descending at a rate of 2,000 feet per minute. Not a lot happened here, but we have to write into an equation. Now first off, my rate of change, remember, is my slope. I'm looking for each, per, every, or a blank. Well, notice I see 200 feet per minute, or 2,000 feet per minute. So my rate of change is 2,000 feet per minute. Rate of change is really important as well because it tells us something very important. I know that when I write my units, something per something, it is units of y per units of x. What this tells me is that my x variables will represent minutes and my y variables will represent feet. So this tells me a lot of important information. Not only does it tell me my rate of change number, which is 2,000, but it also tells me what my x variables represent and what my y variables represent. My initial value b, my y-intercept, is the number I'm starting with. In this case, the airplane is already 3,000 feet above the ground. So my initial value is 30,000 feet. Now something also important to recognize that I didn't is that not only my rate of change 2,000 feet per minute, but notice we are descending at a rate of 2,000 feet, which means I'm going downwards. My slope is going to be negative. Now we can write an equation to show this. Usually when we write equations, we like to write it as y equals mx plus b form, but I prefer, especially for word problems, to write it as y equals my initial value, my starting point, which is 30,000, and then write my rate of change, because since I know I'm descending, I'm going to put minus that 2,000 x. So remember, my slope was this 2,000. This 2,000 was descending, so it is a negative slope. My initial value is 30,000. Now you can also write it as y equals negative 2,000x plus 30,000, but this makes more sense to me. And then remember, we did this because it is descending. So because it's descending, we make it minus. If it was ascending or rising, we would have been plus 2,000. Now use your equation to find the altitude of the plane after 5 minutes. This is why this is really important. You have to know, am I plugging this 5 in for x or am I plugging this y in for y? To know that, I'm going to write out what each thing represents. Now, since it's units of y per units of x, this is my units of x. So x represents my number of minutes. And my units of y represents number of feet. So then I go back to my given information. They tell me I need to figure out the altitude or the height of the plane after 5 minutes. Well, I know how many minutes. I know 5 minutes. However, I do not know the altitude. I want to find the feet. This tells me I'm going to plug in the 5 for x. So I'll rewrite my equation. Y equals 30,000 minus my descent of 2,000 per minute. And in this case, it is 5 minutes. So I'm plugging in 5 for x, since x represents my minutes. From here, you just solve. So y equals 30,000 minus 2,000 times 5 is 10,000. And then 30,000 minus 10,000 is 20,000. But this is a word problem, so I want to include units. Y represents feet. So in this case, I now know my question mark. It is 20,000 feet. So after 5 minutes, my plane will be at an altitude of 20,000 feet. I'm going to go a little bit faster for the next ones, but that was just a general way of how to write equations. For example 2, suppose you receive $100 for a graduation present and you deposit it into a savings account. Then each week after, you add $5 to the account. It's always easiest for me to find the rate of change first because each per or every are usually easier words to find versus the general y-intercept terms. In this case, notice we found each. Each week, you add $5 to the account. So my rate of change is 5. And then remember, it's units of y per units of x. So you add $5. Where is it? $5 each week, per week. So we are adding $5 per week. My initial value, my starting amount, well, we received $100. And since it's past tense, that's also kind of a hint that is your initial value. It's something that you already have. I keep adding zeros, $100. So you received $100. Now we can write out the equation. Once again, you can write it in this form, but I prefer to write it with my initial value first. So in this case, the 100. And then you ask yourself, okay, am I adding this 5 or am I subtracting this 5? Well, they tell me I add $5 to the account. So plus my 5x. And once again, it's 5x because that's my rate of change, mx. My initial value is just the b without the x. You could also have written it as y equals 5x plus 100 if you want to keep it in y equals mx plus b form. For word problems, I like to switch it up a bit, but it's up to you. Use your equation to find when you will have $310 in the account. Once again, we have the problem of, do we plug in this 310 for x or do we plug in this 310 for y? Well, let me write it out. Units of y per units of x. My units of x are weeks, so number of weeks. My units of y are dollars, so number of dollars. And then we have to see, okay, which one do they tell us? Well, they tell us we have 310 in the account. I know my amount of money. You need to find when you will have this. We need to find the number of weeks. So how many weeks will it take us to get to 310? Well, this means I'm plugging in for y. So 310 equals 100 plus 5x. And then from here, you're solving equations. I'm going to subtract 100 from both sides. That leaves me with 210 equals 5x. Divide both sides by 5. and you will get x equals 45. Whoops. 42. X equals 42. So we are going to continue. Oh, actually, 42 what? X represents weeks. We want to figure out how many weeks. It will take us 42 weeks to get $310 into our account. Example 3, researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier has a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day, or 600 meters per day. Write an equation that shows the relationship between the thickness of the ice shelf in meters, x days since the discovery. What is the rate of change? Now this one, they don't have our nice little thing we had in the front where we kind of build it together. We kind of have to think through it. So rate of change, once again, means slope. So we're looking for each, per, or every. Well, notice 0.06 meters per day. And remember, it is units of y per units of x. What is my initial value? How much do we start with? Well, in this case, they tell us that my glacier had, past tense, so let's mean as my y-intercept or my initial value, a thickness of approximately 450 meters. How long will it take for the thickness to reach 0? Assuming the rate of change remains constant. So assuming this stays the same over the time. Well, first we have to write my equation. Y equals my initial value, 450. And then you're asking, okay, for this 0.06, am I adding it or am I subtracting it? Well, if I read the problem, it is decreasing. So it's going to be minus. At a rate of 0.06 meters per day, that's my rate of change, I put the x. Then I have to ask myself, okay, what do x and y represent? Units of y per units of x. My units of y are meters, so number of meters. And my units of x are days. So x represents days, y represents meters. And they want me to figure out how long will it take for the thickness to reach 0. So I have to think, okay, 0, are they talking about 0 days or 0 meters? Well, if we're talking about thickness to reach 0, they're telling me I want to be 0 meters. I want to have 0 meters of thickness. And they're saying how long, so how many days will this take? Well, now I know what to plug in. I need to plug in 0 for y. So 0 equals 450 minus 0.06x. Subtract 450 from both sides. Negative 0.06x, negative 450. Remember, we're just doing inverse operations, so I'm just subtracting. And since I subtracted 0 minus 450 is negative 450. And also remember, that minus sign, I bring it down, so it's still negative. So then we're going to divide by negative 0.06. Divide, the top is negative, the bottom has to be negative. 0.06, that cancels out. That leaves you with x equals 450 or negative 450 divided by 0.06, which is 7,500. But it's a word problem, so 7,500 what? 7,500 days. Now those are all slope-intercept problems, but sometimes you will encounter word problems in standard form. If you're given two constant rates, so two rate of changes, and a total amount, then we're going to be writing it in standard form. So the word problems look different when we are writing in slope-intercept form versus when we're writing in standard form. And you'll kind of get a hang of the pattern. So if we look here, you are running a concession stand at a basketball game. You sell hot dogs for $1 and sodas for 0.5 or 50 cents. At the end of the night, you made $200. Let X represent the number of hot dogs sold and Y represent the number of sodas sold. Well, they kind of told you. X is hot dogs, Y is sodas. And each hot dog I sell for $1, and each soda I sell for 50 cents. C represents my total amount, total C. Well, you made $200. I can build it all together. Instead of writing AX, I'm going to write 1X, or just X by itself, plus, because you're increasing the amount, or you're adding how much people spend on soda plus the amount they spend on hot dogs, 0.05, or 0.50, my bad, Y equals my total, 200. For these, you do not have to solve. You are just practicing setting up standard equation problems. So you're just taking the rate of change for your hot dogs, $1 for each hot dog, the rate of change for your soda, 50 cents per soda, and making it equal to your total amount, which is you made $200. Here's another example. Theater tickets sell for $36 for adults and $24 for students. The total income from ticket sales is $28,800. My first rate of change is the rate of change for adults. It's $36 per adult. And then we have a second rate of change. It's $24 per student. So you're paying different amounts, or you have two different rate of change versus whether you're an adult versus whether you're a student. And we have a total $28,800. So once again, we're not solving, we're just setting up the equation. I'm going to replace A with 36. So instead of AX, I'm going to write 36X. I'm going to replace B with 24. So instead of BY, I'm going to write 24Y. I'm going to replace C with 28,800. And that's my formula. You do not have to solve it, you're just setting it up. So these are the notes for your 3.4 or 4.3 notes. If you have any questions, feel free to come to tutoring. Start your practice in your packet. And once again, have any questions, ask your teacher, send them a question via email, or just stop by. Have a nice day.